So I have this circle over here, and we're going to talk about the line that is tangent to a circle. So I'm going to go from my center, okay? From my center, I'm going to draw a line that is straight out right here. That one right there. Best to my ability, draw that right there, okay? Then, so it hits at one spot right here, okay? Then what I'm going to do is I'm going to take another line, and I'm going to draw the tangent point to that line. Kind of like that. And this will say it goes off in both directions here, okay? So, what do you notice about that particular line and that radius, right? This is my center, this is my radius. What does it look like to you?
Perpendicular.
Yeah, perpendicular, right? So doesn't it look like that makes a right angle right there? Perpendicular. Okay, so here is the theorem. It says, if a line is tangent to a circle, okay, so here's what it says. If a line is tangent to a circle, so I have circle O, I have my radius R, I have the point of tangency right there on the edge, I have line L, so if line L is tangent to circle O, then that line is perpendicular to the radius drawn at the point of tangency, so meaning that there's a right angle right there, okay? So I'm going to try and give you a break on this one. We have P and Q, so we have if P, then Q, where P is this statement, a line tangent to the circle, and Q is this statement, it's perpendicular to the radius drawn to the point of tangency. What would the converse be? If Q, then what? Then P, okay? So you need to be responsible for both, the converse and the theorem. Is that fair enough? Trying to save you some time? Okay? Okay, here's the idea for this one. Two tangent segments from a point. So I have a circle here, and I have a point over here, this little black point up in the top left, and I have this little black point over here, right here. So what I'm going to do is I'm going to draw a tangent line from that point to my circle. So it would have to be something like that. Would you guys agree with that? Or a tangent ray, or a tangent segment, I should say? Is that cool with you guys? You guys agree with that? Okay, and then I'm going to draw another one over here. Because after all, I could draw two of them, right? Kind of like that, if I could draw it to the best of my ability. So I would say the point of tangency is about here, and the point of tangency is about there. Is that kind of fair enough for freehand? Okay, I'm going to do the same thing with the other point over here. I'm going to go from the point, tangent, so I would say right about there, close.
Where are you drawing your line to? Like, what are you trying to hit?
I'm trying to go tangent to my circle from my point there.
But like, at what part of the circle are you trying to
The only part that it only hits at a point of tangency is only one spot. Okay, the point, yeah, it has to skim it, exactly, it has to skim it. So I'm trying to do my best, but I'm not getting a lot of freedom here with that. That's pretty good. And then let's see, how close can I get this? That's pretty good there. Okay, again, not getting a whole lot of freedom, but trying to get these to the point of tangency. There's only one spot. Okay, so you can draw two tangent segments. So we're talking about tangent segments, so I can draw two of them from each point. Here's a tangent segment, and here's a tangent segment for that point, and here's a tangent segment, and here's a tangent segment for that point. Is that fair enough to say so far? Okay, if you had to take a guess, what would you think is true about those two tangent segments? Yes, sir.
They're isosceles.
They're congruent. Very good. You guys are absolutely right. Here's what we're saying. Tangent segments to a circle from a point outside the circle are congruent. So what that means is the yellow lines are congruent to each other. The blue lines are congruent to each other. So any point that you draw outside the circle and you draw the tangent lines to it, I'm just freehanding these, they will be congruent to each other.
Does the circle with a dot in it?
Yep, this little symbol means circle. Yep, that's a little shorthand way to say circle. It's a circle with a dot right in the center. Okay? Okay. Inscribed and circumscribed polygons here. Okay? Yeah, no, the triangle. I have a triangle and I have a circle. Okay, there's two ways that we could say this, okay? What's one way that we could say this figure right here?
The circle is inscribed in the triangle.
A circle is inscribed in in a triangle. Right? That's one. A circle is inscribed in a triangle. What's the other way that we could say this statement? A triangle circumscribed. Yeah, very good. About a circle. We just about the circle means all the way around. About the circle. That's okay. Yeah. Yeah. All right. So let's talk about the difference between externally tangent circles and internally tangent circles. We'll do externally tangent first. Notice that the two circles are tangent. They touch it exactly. They have one point of tangency, which is right there, but they're external, right? Versus an internally tangent circle, right? Which means they still have one point of tangency, except one circle is on the inside of the other. So we have an internally tangent circle, and then we have an externally tangent circle. Here's the question I have for you. Taking a look at these two circles here, we have something called common internal tangents, common external tangents. So I have two circles. I have the bigger one and I have the smaller one. The question I have for you, I want you to think about right now, is how many ways can you draw a common tangent line between the two circles? Okay? I'll give you an example of what that would be. Here is a common tangent line. I've got, it touches there, and it touches there. That right there, that one, and we'll make this pink, okay? Boom. That is a common tangent line. How many of these can you draw? What do you think? Infinite? I'm not sure.
As long as there's circles on. You can draw one.
Can you give me another one?
Yeah, like, oh, at the bottom.
Okay. The bottom one? This one?
Yeah.
Oh, and then
There's only two.
no, and then the one from the top.
Now remember, what's it mean to be a common tangent? Is it okay if the lines cross at a point over here?
Yes.
Yeah, that's okay. We're just talking about there's a common here, right? Now.
The top of the little circle to the
Ooh, very good. I'm glad that you see that, okay? What about the top of the little circle to the bottom of the little, this one here, right?
Oh, but you have to tilt it.
Hold on, I'm going to do my best. Hold on. I don't give a lot of motion here.
It's close enough. But we get the point.
It has to be perfect. Okay. All right, we'll make this one blue, okay? Okay, that one's blue. Can I do another one?
Yeah.
Okay, let's do another one, right? Do you see the other one?
Two triangles from that?
Oh, you sure could. Okay.
I can smell something.
Ooh, that one is pretty good. Okay, that was pretty good.
We should make that one blue again.
Okay, there we go. So check this out. There's four of them, right? I have all these points of tangency. I have this point of tangency for that one. I have this point of tangency. I have this point. I'm doing my best to sort of draw these, with my computer here as best I can. Okay, so if you had to guess, which ones are the common internal tangents, and then which ones are the common external tangents? What do you think? Yeah, Ryan.
The internal ones are the ones like inside the X, like inside the pink line, the blue ones.
Yeah.
And then the external are the ones on the pink line.
Yeah, you got it. So the pink are the common externals, and the blue are the common internals. Does that make sense to you guys? Yeah? You sure it makes sense?
Yeah.
Oh, all right, good. The official way,
So the red or the pink, the blue is what?
the common internals. The official way is to draw a segment between the diameters. Okay. Okay. Common internal tangents cross that segment. Cross the line segment. And external tangents do not. Do you see the difference between the two? So if you draw a segment that connected the two diameters, the internal tangents would cross that line, and the external tangents would not. That's the official way of actually saying it. Okay? Okay, I'm going to stop.